Hello everyone. Today we are going to learn about squares and square roots. That's chapter number 6 of grade 8. Chapter 6 of grade 8. Okay. So this video I will be explaining you the basic introduction of the chapter, all the methods, a complete concept which we have to explain in this chapter. Everything will be covered in this introductory video. Okay, so let's talk about the square and square root first. As you see, there are two terms in the chapter, right? Squares and square roots. So let's take one by one. First we will understand squares and then we will go on square roots. So children, as you have studied already that plus and minus are said to be inverse operation, and we know that multiplication and divisions are said to be the inverse operation of each other. Similarly here, if you see, the square and square root are said to be the inverse operation of each other, right? If I take one quick example to explain this, if I say the square of 2 means 2 square is 2 into 2, which is 4. And if you find the square root of 4, this is the sign for the square root, will be 2. And how it is 2, that we will definitely understand when we will learn the methods to find the square root. If I take another example, say the square of 3, which will give you 3 into 3, which is 9. And if you want to find the square root of 9, this is the factorization, and from this one group I get the square root of 9 is 3, which is again the same number. So we have understood that as plus and minus, multiplication and division are inverse operation. Similarly, we say square and square root are said to be the inverse operation of each other. Okay, so for any number, if I write any number a, the square of a is a square, and again the square root of a square will give you a into a, and you get a. That's the same number for which you have get the square, which was a square. Okay, so we conclude that the square and square root are operation of each other. So in this chapter, first we will talk about the properties of square, then we will go on the main topic, which is the square root in this chapter. Okay, so wherever you feel, you can pause the video to note down the details. Now I will talk about the properties of squares. Okay, so first property which I am talking about is the square of any even number. Square of an even number will always be a even number, right? We can understand it with the example. If I take the example, say any even number, if I take 4 and the square of 4, I expand it, 4 raised to the power 2 means 4 into 4, which gives me 16, and 16 is again an even number, right? Similarly, with this same property, I can conclude that square of an odd number is always an odd number, right? You can pick any example, not only the one which I am showing you over the screen. If I take any odd number, say 7 square, 7 is an odd number, expand it 2 times, 7 into 7, which is 49, and 49 is again an odd number, right? So the first property which we conclude about the squares is that the square of an even number is always an even number, and square of an odd number is always an odd number. Okay, let's talk about the second property of the square. See children, if I write the square of the given number, 1 square is 1, 2 square we know it is 4, 3 square is 9, 4 square 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and 10 square is 100. And I suggest everybody to learn at least up to 20 the squares of all the numbers, right? It should be mentally, every student should learn the squares at least till number 20. So second property, if I give you a number, say I am taking one example, say 92 square, okay, and I want to know without calculating the unit place digit of the square when you calculate of 92. So how do we do that? We will see the unit place digit of the given number, which is 2, and the square of 2 is 4, right? So the unit place digit when you will calculate the square of 92 will always be 4. So these kind of questions sometimes being asked in the mental mathematics or the multiple choice questions, where you don't need to calculate the complete square, rather only looking at the unit place digit and taking its square, you will come to know what will be the unit place digit in the square of 92. If I pick one more example, say 24. So what is the unit place digit here? 4, and 4 square is 16. So the unit place digit in the square of 24 will be 6. As in we know the square of 24 is 596. So you see the unit place digit is 6 here. So this is the second property of squares. You can always tell without solving the unit place digit in the square of the given number. Okay. Now the third and very important property of squares, see for the smaller numbers like the square of 10, like the square of 7, like the square of 14, we can directly write, right? But if we have bigger numbers, suppose I want to find the square root of 62, the square of 62, or I want to find the square of 100, we make use of algebraic identities. Sometimes even the questions categorically come like find the square of the given number using the algebraic identities, right? So algebraic identities, which we have already studied, I will give you a recapitulation of both the identities. A plus b whole square, which is equals to a square plus 2ab plus b square. How the a plus b whole square is equals to a square plus 2ab plus b square? This proof I will be explaining you in my video when I will be explaining algebraic identities chapter. Okay. Similarly, the second identity we have a minus b whole square, which gives you a square minus 2ab plus b square, right? So using these two identities, using these two algebraic identities, we will learn to find the squares of the given number, right? You can pause the video to note down the identities. If I want to find the question I am asking you, find the square of 62 using algebraic identity. So what I will do it, I can write it as 60 plus 2 whole square, right? Now how will I explain? Using a plus b whole square, which is equals to a square plus 2ab plus b square. If I compare this, what is a in my equation? 60. What is b there? 2, right? So now putting the values, a square means 60 square, b square 2ab, 2 into a which is 60 into b which is 2 plus b square again which is 2 square. What is 60 square? 6 6 are 36, adding 2 zeros to it. Then this is 240 and this becomes 2 2s are 4. If you add it, how much it will be? 2, then this is 4, 8 and 3. So the square of 62 is 3842, which we have calculated using the algebraic identity a plus b whole square. Similarly, if I ask you to calculate the square of say 100 using algebraic identities, okay, so what we will be doing? Now I can write, if I ask you the square of 99 rather, right, 99 square. So I can write it as how? 100 minus 1 whole square, right? And we have learned the identity a minus b whole square as a square minus 2ab plus b square, right? So if I compare this with the given equation, my a is 100 here and my b is 1. On substituting the values, a square means 100 square minus 2ab means 2 into 100, my b is 1, plus 1 square. 100 square means 10,000. Sorry, this will be your minus 200 plus 1, which gives you minus 200, and you get 1089. 9801 will be the square of 99. As in 100 square, we directly know it is going to be this. So I have taken 99 square so that you can apply the identity a minus b whole square, which gives you the square of 99 as 9801. Okay. Now you can note down, you can pause the video wherever you want to note down something. I am moving to the last important identity of the squares, which I will be quickly discussing with you. So this is very important. Number containing any given number containing 1, 4, 9, 6, 5 and even number of zeros are said to be perfect square numbers, right? If you see, we have just on the last screen, square of 1 was 1, 2 square was 4, 3 square was 9, 4 square was 16, 5 square was 25, 6 square was 36, if I go ahead, 7 square was 49, and 8 square was 64, 9 square is 81, and 10 square is 100. If I take it from here only, you see, we are having 1, so I have taken a digit 1 here. Next is 4, which is again here 4. Then 3 square is 9. 4 square is 16 and unit place digit is 6, so I am taking 6. And similarly, 5 square is 25, so I have taken 5. If I take 6 square, 36, 6 is already there, it's a repeated digit, so we can skip it here. Similarly, 9, which is a repeated digit, 4, 1 and even number of zeros. So such numbers, like if I give you the square root of 529 and I say whether it is a perfect square number or not, so only at looking at the unit place digit, which is in this case is 9, and we know 9 is listed here, so we know it is going to be a perfect square number. Yes, it's a perfect square number. Okay. Now what digits we are left with? We are left with 2, 3, 7 and 8. So numbers having 2, 3, 7 or 8 at the unit place digit are said to be non-perfect square numbers. Okay, so I can conclude it, the numbers which are having 1, 4, 9, 6, 5 or even number of zeros at their unit place are said to be perfect square numbers, and the numbers having 2, 3, 7 or 8 at their unit place are said to be non-perfect square numbers. Okay, so these were the 4 important properties about the squares. Now I will be shifting to the important topic of this chapter, that is your square root. Okay. So in grade 8, we will be learning, I told you the symbol of the square root is already like this. This is a symbol for the square root. We will be learning 3 methods to calculate the square root. Number 1, prime factorization method. The second method will be repeated, or in some books you will find it as successive, repeated or successive subtraction method. And the last method which we will be using in most questions and is very important from grade 8 point of view is the long division method. Okay, so for using long division method, we will be doing it for decimal numbers and for non-decimal numbers as well. Okay, so I will be taking all three methods one by one with one example. This is just an introductory video, so I will be taking one example, one question to explain you all the methods, and then we will be having the solutions, giving all the exercises in your NCERT book in my next videos. Okay. So let's first understand the prime factorization method. So I know this prime factorization method is nothing new for grade 8 students at least. If I say find the square root of 1764 using prime factorization method. Okay, so we will start solving it. 1764, and we know how to do the prime factorizations. This is 2 8s are 16, then again 2 8s are 16, 2 2s are 4. Then if I do 2 4s are 8, 2 4s are 8 and 1, this goes by 3, 3 1s are 3, then 3 4s are 12 and 7s are 21. Again it is divisible by 3, then 7 7s are 49 and 7 1s are 1. Now here if you see, I have quickly checked that this number is divisible by 3. How? If you sum up the digits, 4 plus 4 plus 1 is 9. If 9 is divisible by 3, it means 441 is also divisible by 3. Similarly, 1 plus 4 plus 7 is equals to 12. If 12 is divisible by 3, it means 147 is also divisible by 3. So I have made use of what? These are said to be the divisibility rules which we have learned in the junior classes. Okay? So it's important that you apply your previous knowledge while solving such questions. Now, how do we calculate the square root? We have done the prime factorization of the given number, which is your 1764. Now, how do we do the prime factorization? So we write the numbers under the square root which are in the prime factors, which is 2 into 2, 3 into 3 and 7 into 7. Now we make groups. There is a group of 2, then we have a group of 3 and we have a group of 7. Taking one digit out from each group, 2 into 2, 2 is out. Then from this group 3 and from the next group it is 7. 3 2s are 6 and 6 7s are 42. So I can say the square root of 1674 is equals to 42. So this was square root using the prime factorization method. We will be doing the prime factors of the given number, then put them, make the groups, and taking one digit from each group, take the product, will give you the square root of the given numbers. Okay, you can pause the video if you want to note it down. Now I am going on the second method, which is your repeated or successive subtraction method. So for understanding this method we use normally, this method we cannot apply for very big numbers, maximum to the hundreds. Okay. So if I say you find the square root of 100, okay, I am taking the bigger number using this method. So for this method, first we have to understand consecutive odd number concept. Okay, so what are consecutive odd numbers? Consecutive means one followed by another, right? And if I want to write the consecutive odd numbers, I will have 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 and so on. So as the name says, successive subtraction. So from the given number, we will keep subtracting the consecutive odd numbers till the time we get a 0. Okay, so how do we do that? Let's start doing it. The number is 100. 100 minus 1 giving you 99. Now you do 99 minus 3, which gives you 96. 96 minus 5 gives you 91. 91 minus 7, 84. 84 minus 9, 75. 75 minus 11, 64. So I am subtracting consecutive odd numbers, and then 64 minus 13 will be the next number. It gives you 51. The next odd number will be 15 in the series, which gives you 36. 36 minus 17 gives you 19, and after 17 the next number is 19, and here I am getting the difference as 0. Okay, so we have to keep subtracting the consecutive odd number till the time we get a 0. Now how do we calculate the square root? We have to see in how many steps we are getting 0. So let's count the number of steps. If I write it as first step, second step, third step, fourth step, fifth step, sixth step, and then we have 7, 8, 9 and 10. So in 10 steps I got 0 when I subtracted consecutive odd numbers. So therefore the square root of 100 becomes 10. So we have to do it this way. We will keep subtracting the consecutive odd numbers till the time you get 0, and you will check in how many steps you are getting 0 becomes the square root of given number. So this is very interesting, very easy method, repeated, or in some books you will find the word successive subtraction to find the square root of given number. Okay students, wherever you feel you can pause the video to note it down. Now I am explaining you the last method, which is very important method for grade 8 point of view, long division method to calculate the square root. Okay, so long division method, as I told you earlier, we will be calculating for non-decimal and decimal numbers. Okay, so we will be doing it for decimal number also and for non-decimal number also. So let's first take a non-decimal number. If I want you to find the square root of say 529 using long division method. So how do we do that? So first thing is, when we have to make use of long division method, the first thing you will start making group from the right hand side. This is the right hand side. Group means group of 2 digits. So I have made first group. Now this 5 is unpaired, so this is a single digit in the second group. Okay, so how many groups do I have? I am getting number of groups which officially called as number of periods is equals to 2. We don't say 1.5. Even if there is a single digit, it is counted as one complete period. Okay, and the interesting thing here is the number of periods will be equal to the number of digits in the square root of 529. So when you will find the square root of 529, you will see that the answer contains 2 digits, which is equals to number of periods. So in exams, if sometimes question comes like 1764, how many digits will be there in the square root of 1764? So no need to do the square root. Rather, what you will do, you will start making the periods. How many periods are there? 2 periods. It means in the square root of 1764, the digits will be 2. That is how you can directly calculate the answer. Okay. Now let's learn how to calculate the square root using long division method. If you want to note it down, please pause the video and note it down. I am explaining you the number is 529. We have understood that from right hand side we will start making the groups. Okay. Now you have to divide 5. How do we do that? We will start checking it here on the rough. 1 into 1 is 1, which is of course very much less than 5. Now you take second pair, 2 into 2, 4, which is again less than 5. If you go on next, which is 3 into 3, gives you 9 but greater than 5. So we will stick to 2 into 2, which is 4. So I put it here, I put it in quotient and divide it by this, take the difference, gives you 1. Now very interestingly, as in division we copy the next digit, here we copy the complete pair, the complete period, complete group, and here you get 129. Okay. Now the sum of this digit and this digit, how much is it? Is 2 plus 2 gives you 4. You have to place one digit here and the same digit here. So we will again start making the groups. Suppose I say 41 into 1, which is 41, very much less than 129. So you see this digit and this digit remain same. I'll try next 42 into 2, again 2 and 2. So this is how much? 84 again very much less than 129. If I take 43 into 43, this gives me 129, which is exactly equal to which I want. So I put it here 43 and then 43, 129, take the difference which gives you 0. So I can conclude the square root of 529 is equals to 23. Okay, so I am again explaining this method with the same example. If you have the number say 529 for which you have to calculate the square root. So first thing, this is your right hand side, right? So you will start making the groups. I have made first group as 29 and this 5 is your single digit in the second period. So you have to divide 5. I have taken 1 into 1, which is 1 very much less than. So we can try the next, which is 2 2s are 4, again less than. 3 3s is 9, which is greater than 5. So I have taken 2 2s are 4. Take the difference which gives you 1. Remember here you have to copy the complete period, not only the single digit. So I have copied 29. 2 plus 2. How this 4 has come? 2 plus 2. And then again you have to place the same digit here and same in the quotient. So we have tried till the time you get a number less than or equal to the number which you have to divide, and you are getting a remainder 0. Okay, and you see the square root of 529 is 23. So this was the method which we used for a non-decimal number. Now the method remains same. Like in division, what we do? If we have, suppose I'm asking you to find the square root of a number 12.25. So in division, whenever there is a decimal, we place that decimal into the quotient. So similarly here, what we will do when we have to find the square root of a decimal number, again as per the rule, we will start grouping the digits here first and second. So number of periods, how many are there? 2. So one thing I can make it out that the solution will be containing 2 digits only. That I can make out without even finding the square root of the given number. Now 12, you have to divide 12. So we will again start 1 1s are 1 less than 12. 2 2s are 4, which is again very much less than 12. If I go 3 3s are 9, which is again less than 12, and then 4 4s are 16, which is greater than 12. So I will be sticking myself to 3 3s are 9, right? So taking 3 3s are 9, subtract it 3. Now you have a decimal before you copy the next period. So same as division, you will be placing this decimal in the quotient before you copy the next pair. Okay, now 3 plus 3 gives you 6. Again you have to place one digit here. So we will again try the combinations. If I say 61 into 1, 61, 62 into 2, 124, 63 into 3, 189. If I go 64 into 4, 256. If I go 65 into 5, which gives me same 325, right? So I can take 5 here and 5 here, and you take the difference which gives you 0, right? It means the square root of 12.25 is equals to 3.5. So this is one method. I have seen many students what they do. If I am going on the next page, when you have to calculate the square root of 12.25, the another way that you make it a non-decimal number by removing its zeros, right? And we have just calculated its square root is 35 upon 10, which again gives you 3.5, right? So it's the same thing. If you want to make it, convert it into a non-decimal number, you can remove the decimal and add equal number of zeros in the denominator, and you can follow any way. Okay, so these were 3 methods which we have just practiced one question, as it is just an introductory video. So with repeated subtraction we have done, with the prime factorization, and with the long division method for decimal and non-decimal number. Okay, now there is one more concept in grade 8th which I am going to explain you, is about the Pythagorean triplet. There's a last concept which I need to explain you, and then we can start the exercises. So Pythagorean triplet, For this to explain, I will have a quick recapitulation of the Pythagoras theorem. We know the Pythagoras theorem holds true for the right angle triangle, right? So if I take this as a right angle, this is my hypotenuse A and I take it as B. Okay, so if I am taking A as a perpendicular, B as the base of this right angle triangle, C I am taking as a hypotenuse, right? And we know that hypotenuse is the longest arm, so C will be greater than A, C will be greater than B as well, right? And in any right angle triangle, we say A square plus B square is equals to C square. That's your Pythagoras theorem, right? So here A, B and C, what we say, where A, B and C will be your positive integers. Positive integers means they cannot, if you understand it from the number line, this is your 0. On the right hand side of the 0 we have positive, on the left hand side be negative, so they will always be greater than 0, right? Then only they can be the positive integers. So with this, if I say you a combination, say 3, 4 and 5, are these three members are the Pythagorean triplet? So you see, what is the highest member here? 5. So my C is equals to 5 and A I can take 3 and B I can take as 4. So placing them in A square plus B square is equals to C square will give me 3 square plus 4 square is equals to 5 square, which is 9 plus 16 is equals to 25. So here LHS is equals to RHS. It means 3, 4 and 5 are forming Pythagorean triplet because they are satisfying the equation A square plus B square is equals to C square, right? If I take one more example to explain this to you, let's take 5, 12 and 13. Okay, so the highest number here is 13. So C becomes 13 and I can take A as 5 and B as 12. From the Pythagoras theorem, the relation is A square plus B square is equals to C square. Place the values, 5 square plus 12 square is equals to 13 square. Okay, so this gives you 25 plus 144 is equals to 169. If you add 25 plus 144, 169 is equals to 169. LHS is equals to RHS. So it means 5, 12 and 13 are said to be the Pythagorean triplet, right? Because it satisfies the Pythagoras theorem statement, which is A square plus B square is equals to C square. So in your syllabus, there will be one member of the Pythagorean triplet will be given and you will be asked to calculate other two members. So how do we write it? For any natural number, I am taking say m greater than 1. M greater than 1 means it is more than 0 on the right hand side of the number line. If you want 2m square plus m square minus 1 square is equals to m square plus 1 whole square. So I am again taking Pythagoras theorem here. This is my right angle. So this is my C here, this is my A here and say this is my B here. So C square means m square plus 1 whole square will be equal to A square plus B square. Now let's prove it. If I expand the bracket, what it becomes? 2m square matlab 4m square using the identity A minus B whole square minus 2m square plus 1 is equals to A plus B whole square, which gives you m raised to the power 4 plus 1 plus 2m square. Now if you see, I can cancel this with this as they both are with the same sign, implies 4m square and minus 2m square are like terms. I can subtract plus 1 on the other side also I have 1 plus 2m square. So again LHS is equals to RHS. It means these three members are satisfying the Pythagoras theorem. So to generalize it, what can I say? That 2m, m square minus 1 and m square plus 1 forms Pythagorean triplets. So these three triplets we will be using to solve any question. Okay, please pause the video and note it down before I explain you with one example. Okay, so we have written that the Pythagorean triplets can be written as 2m, m square minus 1 and m square plus 1. And let's understand this with one example. If I say one member of the Pythagorean triplet is 12 and find other two members. So how do we are going to calculate it? So one member, if it is given 12, so out of these three members, if I place 12 equal to any of the member which can give me the value of m, I can calculate all. So the simplest thing, if I put 2m is equals to 12, from here m gives me 12 upon 2, wherein m becomes 6, right? 2 6 is 12. So I am having the value of m as 6. Now to calculate other two members of the triplet, if I place m square minus 1, value of m I have already calculated, which is 6, 6 square minus 1, which is 36 minus 1, and hence 35 is the second member of the Pythagorean triplet. Then I calculate third member, which is given m square plus 1, the value of m remains same, which we have calculated in the first part, 6 square plus 1, 36 plus 1, and hence 37, right? So we can write hence the Pythagorean triplets will be R, m will be the first member which was given to you is 12, not 6, then m square minus 1 is 35 and 37. And if you want to cross check, as we have did in the Pythagoras theorem, that c will be 37, so the square of 37 should be equal to the square of 12 plus 35 square. They will always satisfy the Pythagorean theorem. Okay, so this is how when one member is given, we can calculate one member which was 12 was given, we can calculate the other two members of the given triplet. So this was one important topic in this chapter. We have covered all the concepts. So far in this chapter, we have understood the properties of the squares. We have learned how to calculate the square root using prime factorization, repeated subtraction method, which is also called as successive subtraction method, and the long division method for decimal and non-decimal numbers. And we have understood about the Pythagorean triplets. With this, I complete the introduction part of this chapter, square and square roots. For the solution and for the understanding of the exercises questions, please see part 2, part 3 and part 4 of the same video. Till then, if you have any query, please put it in your chat box. I will be taking all your doubts in my next video. Thank you.